Why use experimental probability? What is it used for? Experimental probability is probably determined from the results of an experiment. Why use it? Why use experimental probability? Can't we just use theoretical probability, you might be thinking? Well, not all situations allow for theoretical probability. For example, let's think science. The probability of an operation being successful, those results come from trials. There's no theoretical probability of that. They come from actual operations and results being recorded. So think about this table. So here I have 4 results from 4 operations, each operation being considered a trial. If I want to know the probability of success, I would count my successes. This one's not a great success rate because, as you can see, the number of successes, well, there's 2. There's 4 trials, so 2 out of 4, that's a 50% success rate. Some situations you can do experimental as well as theoretical. And in theory, experimental probability should be approximately the same as theoretical after many, many trials. Let's think about rolling a die. If I roll a die and I want to know the probability of getting a 6, I know the theoretical probability of rolling a 6. Is, because there's 6 sides, it's 1 out of 6. Now let's try an experimental probability. I'm going to roll the dice only 6 times. Is that many trials? Absolutely not. That is very few. So let's see if we get lucky. I'm going to count the number of 6s I get. So create a tally here. So first roll. That's a 2. Second roll. That's a 1. Third roll, I got a 6. Fourth roll, I got a 1. Fifth roll, I got a 2. And lastly, 6th roll. Oh, I got lucky. The probability of rolling a 6 in my experimental probability was also 1 out of 6.